وعليكم السلام.
السلام عليكم.
نعم، السلام عليكم ورحمة الله وبركاته.
السلام ورحمة الله.
عليكم السلام.
ورحمة الله وبركاته.
Now, today we are moving to 3-terminal devices. Previously, from our past classes, we'll be treating two-terminal device. So we treated diode as two-terminal device, and we also treated PN junction. But today we are moving to three-terminal device. So of which we will focus on two of the three-terminal device, which is MOSFET and BJT. For the time being now, we will start on MOSFET. The meaning of MOSFET is metal oxide semiconductor field effect transistor. Anyway, the theoretical aspect of this, you should read on the theory. So that is just the meaning of MOSFET. So we will treat MOSFET under two major modes of operation. That is the saturation mode and the triode mode. So our analysis will majorly based on the two, because we will have to write the current that flow through this device. They have different formula. So the formula to be used depend on the region of operation of the device. So we base our analysis on the two modes, which is saturation and triode, because for the cutoff mode, we know that ID will surely equals to 0. It means that there is no current that flows through the device. So in that case, we base our analysis on saturation and triode region. So you must know the exact equation to be used in a particular type of operation. Sometimes from the question, it will not be stated that the MOSFET is operating in triode region or the MOSFET is operating in saturation region. But you can know that there are some determining equation. We have one equation for determining whether a particular MOSFET is in triode region or is in saturation region. Whether it is in triode region or is in saturation region. That is, for saturation region, please, this formula is very, very important. Is very, very important. That is, the VDS is greater than or equals to VGS minus VT. So when this condition holds, it means that the device is in saturation region. When VGS less than or equals to when VDS less than or equal to VGS minus VT, it means that the device is in triode region. Another name for triode region is also known as what? Who can tell me? Another name for triode region. Anybody? Assalamu alaikum.
We only know it as triode region.
Oh, there is triode region is also known as linear resistance region, because if you know in diode region, you know triode region behave like an IV curve. It's like an IV curve. Because of that, they call it linear resistance region. Because in some question, it will not be stated that it is in triode region. It will just be stated that you should assume that it is operating in a linear resistance region. The moment you see such question, you should know that it is in triode region. And for triode region, your VDS, that is the voltage between the drain and the source, must be less than or equals to VGS minus VT. That is when you want to use VDS as determining factor to know whether the device is in saturation region or is in triode region. Another important factor is VDS minimum is equals to VGS minus VT. In this case, the device is said to be in pinch off. You know the meaning of pinch off? So sometimes you will be asked which condition satisfy the pinch off of MOSFET. So you should know that it is very, very important. In some textbook, Instead of you using VDS as your factor, some people use VGS and threshold voltage, that is VT. When VGS is greater than threshold voltage, it's known as in saturation region. When VGS is less than or equal to the threshold voltage, it's known as in triode region. And for pinch off region, it's a must. You have to use the VDS minimum to be equals to VGS minus VT. When this occurs, it means that such device is in pinch off region. So these are just simple things you know. So now for saturation region, this is the IV, this is the current, the formula for finding current in a saturation region. This is the formula for finding current in a saturation region. Please, it is very important, don't mix the formula. For saturation region, this is the formula, 1/2 Kn prime. So I use subscript N because I assume that my MOSFET is an NMOS. So if it is PMOS, you have to use Kp. You have to put P here. You understand now? So my triode region, you have, this is the formula for finding the drain current, the diode current, or the drain current flowing through the device in when it is said to be in triode region. So let's see some questions. When we solve question, I know it will be clearer. So question 4.12. A particular enhancement MOSFET for which VT equals to 1 volt and Kn prime W/L is equals to 0.1 milliamps per V square is to operate in saturation region. Alhamdulillah, it is stated here that it is to the diode is operating in saturation region. These are the key things you need to highlight. It is very important. You must know the one. It is what? In saturation region. Saturation region. It is very important. You have to highlight that. Another important thing is it is an enhanced. I want to ask you some question here. Enhancement mode MOSFET. Okay. And we have to find what? Find the required VGS. You want to find gate to source voltage and the minimum required VDS, minimum VDS. And we have to repeat the same thing for ID is equals to 0.8. Now, my question to you now is, when is MOSFET said to be in an enhancement mode? Who can tell me? When is MOSFET said to be in an enhancement mode? Are you with me? Please, if you don't know it, just say you forget so that we can move on, please.
Yeah, we don't know.
Okay.
No,
Please.
teacher. If the VT is positive, is the enhance.
When
But
VT
in the
is what?
negative, but if the VT in the negative, it will be depletion.
When VT is negative, is enhanced. The answer, what you gave is not that correct. Do you know why? Because if you say it is when VT is negative, it is enhanced. What about if the MOSFET is a PMOS? You know, for a PMOS MOSFET, your VT is always negative. You understand? That's the reason why in the formula for finding ID for a PMOS MOSFET, we always use modulus here. We use modulus like this. You put modulus like this in VT, so that the negative will cancel out. So
Yeah, right.
the condition you gave me now is not really very okay, because
Or maybe from the circuit.
what did you say?
From the circuit. The structure of circuit.
From
In
the
MOSFET,
circuit.
there is an arrow. Yes.
Okay, let me just give you simple way to know that your MOSFET is in an enhancement mode or in depletion mode, because this type of question can come out in your MCQ, and it's very important you know it. So MOSFET has to be in an enhancement mode when your VGS is greater than VT. The moment the VGS gate to source voltage is greater than VT, then it will be in an enhancement mode. Just stick to this one. Whether positive or negative, it can be confusing, because if this one is PMOS, you know VT is always negative, then there will be a confusion. I understand what you are saying, but it is better you stick to that. You understand now?
Yes.
Okay, so it is in enhancement mode when your VGS is greater than VT. So now let's
But
solve this
teacher,
question now.
excuse me, but in the depletion region, this is the same, yes? Or
No. For depletion mode MOSFET, you reverse it.
okay.
You understand? You reverse it. Instead of VGS greater than this, it will be in opposite direction. Clear?
Yes,
clear.
clear.
Okay. Now, so from the question they said is what? Saturation region. Then in that case, sorry, let me clean this one. Okay. In that case, you use this formula. You know your ID is given to be 0.2. You know Kn prime W over L to be 0.1 milli. So you can find VGS straightforward. Now you can see that from here, my VGS minus VT squared. If you divide this one by this one, you have 4. Square root of 4 is plus or minus 2. Then this minus will come here, it will become plus 1. You take the positive, you have 3. You take the negative, you have minus 1. Clear? Now, looking at this one, between VGS plus 3 and VGS minus 1, which one should be our correct answer to choose? I want to test something now. Don't forget,
The
they said what?
The positive is our answer.
Yes, the positive is the right answer because this is in saturation region. And we know that for saturation region, the condition is the VGS must be greater than VT. Because if you choose this one is less than VT, which is 1 volt. Please, it is very, very important. Just take care of that. Now, the next question is we should find what? The minimum required VDS. So the minimum required VDS occur when the device is in pinch off. You can see this is the condition for pinch off. This one. Alhamdulillah. So this is the condition for pinch off. So you have to choose the positive value of VGS. 3 minus 1. You have 3 volts. 2 volts, sorry. So please, you can try when maybe in your leisure time, try when ID is equal to 0.8 and see what will happen here. So you can try that yourself. Is it clear, please? Clear?
Clear. Yes, clear.
Okay. So let's now move to question number 2. Let's move to question number 2. I'm trying to clean up this one. Okay. Question number 2. A particular N-channel enhancement MOSFET is measured to have a drain current of 4 milliamps at VGS is equals to VBS, which is equals to 5 volts. At VGS is equal to VDS, which is equal to 5 volts. And 1 milliamps at VGS is equal to VDS, which is equal to 3 volts. Please give me 1 minute, please. Someone is, please, 1 minute, please. Now, assalamu alaikum. I'm sorry, please. So, what are the value of Kn prime W over L and Vt for this device? Now, from this question, this is the type of question I'm trying to explain the other time. Looking at this, we are to find the value of Kn prime and the Vt. Number one, before you can start solving any question, you must first determine which region of operation this type of device is operating on. Who can tell me which region of operation is this one working on and why? Who can tell me which region of operation is this one?
It is saturation.
It's saturation. Why is it saturation?
Yes. Because
Why?
VGS equal to VDS.
Because VGS is equal to VDS. Because VGS is equal to VDS. Fine. So you can see that for VGS is equal to VDS, it means that what? It is in saturation region. Please, make sure you know all these conditions. If you know this condition, you will not have problem under this question, this type of question, because there is no how doctor will set it for you in your exam. It will surely come out in your exam. So please just take note of those conditions. It's very, very important. So since it is in saturation region, we use formula for finding ID in saturation region. So now in this case, we have two IDs. ID1, which is 4 milliamps, ID2, which is 1 milliamps. So we form the first equation and we form the second equation. Then we divide the two equations, then we have this. This one we cancel out. Then you have the, you can find your VT directly. So VT is equals to square root of this one plus or minus 2. You choose the positive side, you have your VT to be 1. So then you substitute for VT in maybe equation 1 or equation 2. Whether you can substitute it here or you can substitute it in equation 1. Then if you substitute it, you have your Kn prime W over L to be equals to 0.5 milliamps per V square. Please, is it clear? Assalamu alaikum. Hello?
Yes. Salam.
Clear, right?
Yes, clear.
Okay. Now let's move to the last question. This the last question is a standard exam question. Please take note. You may be lucky, maybe doctor will bring the same thing for you, and if you are not lucky, maybe he will not bring it. So I don't know. So an NMOS transistor operating in the linear resistance region. This is what I'm saying. This is what I was explaining the other time. Linear resistance region. Linear resistance region. Is operating in linear resistance region. This one. So it means that what is in which region? Triode region. Triode region. With VDS is equal to 0.1. Is found to conduct this current for VGS is equal to this, and this current for VGS is equal to this. So we have two IDs. So what is the apparent value of the threshold voltage? We want to find VT. If Kn prime is equal to this, what is device WL ratio? We want to find device WS ratio. Then what current will you expect to flow with VGS equals to 3 volt and VDS is equal to 0.15 volt? If the device is operated at VGS is equals to 3, at what value of VDS will the drain, at what value of VDS will, at what value of VDS will the drain end of the MOSFET channel just reach pinch off? Will the drain end of the MOSFET channels reach pinch off? So meaning that you have to use condition for pinch off region here. And what is the corresponding drain current? This question is a very good question, very good exam question. So from the question, you have two IDs. So, sorry, let me clean this one. Now, since it is a linear region, it means that what is a triode region. So you use formula for triode region. We have the first ID to be 60 microamps, and the VGS is given to be 2 volt. VDS is 0.1 volt. For the second ID is 160 microamps, and VGS is equal to 4 volts, sorry. So we have to find VT. It means that you have two simultaneous equations. You know your VDS to be 0.1. You know your VGS. The first one is 2, the second one is 4. Okay. So let's quickly rush through this one because the let me quickly take your attendance. The session will end after 10 minutes. Sorry, I'm trying to take your attendance now. Oh, yeah. Sniping. Okay. Okay. So you substitute for 60 amps and 160 amps. We know V2, VGS will be 2 and VGS will be 4. So from here, if you divide equation 1 by equation 2, you have this. Then from here, you do your mathematics. At the end of the day, we have our VT to be 0.75. This is the value of VT. Then to find Kn prime, if Kn prime, another question, if Kn prime is equals to this, we have to find W over head ratio. You already know your VT now. You just substitute in any of these equations, whether this one or this one, anyone. But the one I solved, I substituted it in equation 1. So you substitute it here, then you can find W over L, which is equals to 10 volts. And another question is, what is the value of ID when VGS is equal to 3 volts and VDS is equal to 0.1 volt? All you need to do is just to substitute for all this one. You know your VT to be 0.75. VGS is given to be 3 and VDS is equal to 0.15. So you can find your ID. Another question is, if VGS is equal to 3 volts, the channel reach pinch off at, that is the condition for a MOSFET to be in pinch off. So it will reach pinch off at VBS is equal to VGS minus VT. So you substitute the value of the VGS and the value of VT that we found, 0.75. Then you have this. This is the condition at which VGS reach pinch off. Now, they now say we should find the corresponding value of ID at pinch off. This place now, you have to be very careful before you solve this question. If you want to find corresponding value of ID at pinch off, which formula are you going to use? For you to know the formula you are going to use, you have to test the condition. Is VDS greater than VGS minus VT? If your answer is yes, it means that this condition is saturation, and you have to use the current in the saturation region, not in the triode region again. But if your VDS is less than VGS minus VT, it means that it's in triode region, and you will use the formula for finding ID in triode region. Now, looking at this, the corresponding value of ID at pinch off. This is at pinch off. VDS is what? 2.25, right? 2.25. Is VGS greater than VDS or VDS greater than VGS? That is, if this is what I'm saying, let me write it out so that it will be clearer. If VDS greater than VGS minus V threshold, this one state that what is in saturation region. That is, you will use ID in saturation. Now look, come back here. If you come back here, your VDS is what? 2.25. VGS what? 3. 3 minus 3 minus VT. What do we have? 2.25. It means that, oh sorry, this is greater than or equals to, sorry. So it means that your VDS is equals to what? Your VGS. You know, from here, if your VDS is equals to VGS, what is the condition for this one? Is it triode or saturation? Can someone answer? We only have like 2 minutes, please. Hello? Hello?
Yes, saturation.
Saturation. Since it is in saturation, because this one now, VDS is equals to VGS from here. So in this case, you will use current in the saturation region. So don't make, if you make mistake and you use current in the triode region, it means that you will miss your answer. So you substitute all your value and you have this. Please, is it clear? Clear?
Yes,
It's clear.
clear. Yes, clear.
Alhamdulillah. So I've already taken your attendance. I think we can, 27 students are present. So I already taken it. So inshallah, we can call it a day. We can end the class if you don't have question. Any question? Any question, please? No question.
No questions. All things clear.
Right? Alhamdulillah. So we can end the class.
Yes.
Now.
No.
Assalamu alaikum.
Assalamu alaikum.
Wa alaikum salam.
How can I find these files?
Which file? You mean the tutorial?
Yes.
Okay. I will try. Alhamdulillah, I'm recording it. So I will send the recording to you on. You have my WhatsApp number?
No email? No, I don't have.
Okay. How can I do it now? And the session will end up in 1 minute. Okay. Let me quickly send it to your chat now. You just send me a message. I will send it to you. Or I will send you a link. Okay. Don't worry. I will generate a link on YouTube. Then I will send it through to everybody in your email. Clear?
Email, okay.
Okay.
Better.
Okay. Assalamu alaikum.
Clear. Thank you.
All right.